Hello, here's my presentation. So, fixing reproducibility through an AI-driven workflow measures for every campus lab at Purdue. A 2024 study by Retraction Watch examined 1,500 computational papers, found 70% could not have been rerun from the materials provided, which is clearly a large majority. Professor Victoria Stodden at the ACM 2020 echoed this. Only 1 in 4 authors supplied complete workflows. A vivid cautionary tale is Duke's Predict Cancer Omics project. After hidden pre-processing steps skewed outcomes, the flagship study was fully retracted. These numbers and narratives reveal our real enemy, invisible undocumented workflows, and not individual negligence. And invisible code breeds unfixable errors. So why does this matter to us? Here's why invisibility solves our issues. Most labs stitch Python, R, Bash, and CUDA together by hand. 6 months later, no one remembers exact packages, versions, random seeds, or environmental variables. Meanwhile, PyPy and CRAN silently replace old libraries, so the same script that ran last spring can now not throw errors. Without an audited trail called workflow prevalence, even first authors struggle to replicate their own figures. Meanwhile, peer reviews don't even stand a chance. And so here's a little graph of 75% of computer-based studies and their reruns, and clearly it's a large majority. Even fields that aren't very related, like molecular biology, are on this chart and have very high errors. So computer science has the highest out of all these. So how do we solve this? Tools like SnakeMate and Nextflow treat each transformation, download, model fit, figure export as a declarative rule that remembers its inputs, outputs, and software versions. Pipelines are rendered as shareable graphs, and they re-execute on what they change. So no more messy pipelines that are hard to read. A 2024 preprint by Wyatt and Renda Joy adds an AI twist. GitHub Copilot autocompletes rule docs and suggests version pins, turning tedious documentation into a keystroke. Transparency becomes default rather than drudgery, while runtime actually speeds up. So here's a little diagram of the input in a black box, which is often AI models and pipelines, and the output. So our goal is to demystify this black box, which is shown by this magnifying glass. Hidden steps and shifting libraries equals cost. An IEEE software pilot by T.D. Tomaso and the IEEE paper in 2023 tracked 12 genomics projects. Replication time fell from 14 hours to only 7, and belt failure rates dropped to all the way 0 after NF core workflows replaced ad hoc scripts. A follow-up Glasgow study found that 80% rise in papers passing independent reproducibility checks when SnakeMate was mandated for grad student theses. These are not only simulations, they're in real labs and various universities rescuing real timelines. And so here's a key benefit of open source workflows. Here's a roadmap. Month 0, approval. Identify 5 volunteer labs across biology, engineering, and computer science. Months 1 through 2, the University of Glasgow Reproducibility Task Force white paper endorsed by Stodden takes rollout under $5,000 per lab. 1 modest server, 2 lunch and learns, and a Copilot license. Compare that to the 150K average cost when a single study must be redone for a journal audit. Factors in saved GPU hours, about 800 per project, and the investment monetizes itself before the next grand report is due. Financially and academically, it's a slam dunk. So here's a roadmap. First month, we seek approval. We identify 5 volunteer labs across biology, engineering, and computer science. And months 1 and 2, training. Provide a grad level TA as a workflow agent. And during months 3 and 5, data collection. And then finally, in month 6, we evaluate and vote. We publish metrics and decide on campus-wide adoption. Because a pilot is small and time boxed, risks stay low, but evidence will be robust enough to move policy. So here's the takeaway. Better science leads to a more predictable campus. AI-enabled workflow managers turn reproducibility from afterthought into a default setting. We safeguard grant money, accelerate delivery, and restore public trust, but only if we start now. Let's run the 6-month pilot, measure the wins, and lead a Big Ten in transparent, reliable computation. Thank you for considering the proposal, and I'm happy to answer any questions.